Hi all, and welcome to this tutorial. In this tutorial, we will combine all what we have learned in the Part 2 lectures into code. We will build a neural network for image classification using logistic regression, which can classify if an image has a bird or not. The Jupyter Notebook link and data used will be made available in the description below. Without further ado, let's get started. I've imported all the necessary libraries into the block up here, just to make things cleaner and easier as we go through. This Jupyter Notebook is divided into two main sections. The first part will be the data pre-processing, and the second part will be the actual designing of the neural architecture. I've also further split this part into smaller parts. Now this will be perhaps a longer tutorial than usual because we will be doing everything from scratch here. So the first thing we need to do actually is prepare our folder structure, and the folder structure looks something like this. So we have a folder called birds, and this is basically going to contain all the images of the birds. In your case, this can be turtles or butterflies or anything that you really want to classify. It goes here. And then you need a folder that's called other images, and this basically contains a mix of other images. And the third folder is your training set, and this is the set of images that we're going to use to train your algorithm, and then the test set, which is to test your algorithm. And at the end here, we're going to show you, I will show you a way on how to add your own image to test with the neural network that is not part of your test set. Okay, so let me show you my folder. So I got the birds, other images, test set, and train set. In the birds, I have all my birds. In the other images, I just have a bunch of random images. Then I have my test set and turn set, and archive is just for me. Okay, so before we load the data sets, if you have scraped the internet of images or you have a folder with images, since this is a supervised learning method, you really need to have the labels. So one method I do to create labels is by actually renaming my files, and by renaming my files I just simply extract the labels from there. So this is one of many methods that you can do. So let's start by actually renaming the files to extract the labels, since this is a supervised learning task. So I'll create a function. Let's call it define random, rename files, which takes in two functions. It will take in the path and it will take in the label. Let's iterate, and then I'm using a Windows machine. So for file name in the operating system, go into this directory. So the path will basically be grabbed from here. So we're going to do a try and accept here. So I'm going to catch my exception so it doesn't break my codes. Yeah, show me this, and then continue iteration. So what will my code do? I'm going to extract two things, which is the file and the extension from my path. So the source file is gonna basically be the path and the file name, and my destination in this case will be the same. So I'm just gonna overwrite the same folder with the new names, and it's highlighted here by the OS rename. Okay, so this is the function. It's gonna take two things. Yeah, I'm just gonna go grab my path, and then I'm gonna call the function. I'm not gonna run this because I've already run it once, or maybe I can run it again. So basically, as you can see here, this is a function that renames files. It takes in two arguments. It takes in the path and the label. It passes the label into the list directory. It extracts the file and the extension, and basically I need the extension here when I'm renaming it. So basically the path will stay the name. It's going to take the label, so it's going to add the label here. It's going to iterate, so that becomes 0, 1, 2, 3, 4, 5, and then just puts the extension back. So if I take a look into my birds file, you can already see I've ran this code, so you see it's already birds and it's iterating, but I think it's, yeah, because I haven't executed this. And I can't find my path name called temps because it's called birds. Yeah. Name file is not defined. Yeah, well, obviously, because I didn't paste this here. Right, and it says it's an error because the file already exists. Yeah, because I've already run this function. But anyways, here you see I have 476 images of birds starting from 0, 1, 2, and it iterates, and that represents the destination here. So you keep the path, it gets the label bird because I've highlighted the bird here, the string, which is 0, 1, 2, 3, 6 packs, the extension, and renames. So now we have renamed our file. The next step is these files are actually way too big for running on a simple CPU machine, or it takes a long time. So what we're gonna actually, you see here the dimensions are 500 by 34. I think they're all quite different. So if we look at this one, yeah, 500 by 333. So what we're gonna do is actually reduce the size of these images to make it easier or to make it faster. So let's create a function. Again, it will take in the source path and the destination path. And same as before, let's just get our try and exception here since it's ready. Just make sure the indentation is correct. Yeah, and well, it's also correct now. There we go. So again, for the file name, so we're just gonna fix this so it's the source path. So taking my source path, and now we're gonna try something else. And if there is an exception, don't iterate in my name, just continue. So try, so open the image for me. Use image open. I think I've imported that library. So of course it's from that source path plus file name. Then I want you to just simply resize it to 64 by 64. If you have a strong machine and you just want to use the whole thing, it's also up to you. If it doesn't exist, if the destination path doesn't exist, then create one. This is just safety, but I highly recommend that you create the destination path that you're gonna pass here. Make sure that it exists. In our case, we're gonna create training set as our destination path. Then just save it with the same file name, so we're not gonna change anything. Give me a message, resize, success. Oops, just here, which file, so I know if there's a file that caused the problem. Right, so that's our function to resize images. I'm gonna go, so we need the source and the destination. So originally I have said, I already closed the file name, so let me just reopen it here, please. Just go to my desktop. So originally I've created birds and other images. So what you want to do now is you want to go grab all the things in other images. You're going to grab everything in other images here and just put it in your birds file. Okay, so now your birds file actually contains a mixture of everything. It contains a mixture of your birds and other images. So I'm just gonna go copy my source path. So essentially now your birds folder contains everything, which is your source, and your destination is gonna be the training set. And your training set is now empty. And now it's going to resize everything and put in your training set. So let's execute this. We got an indentation. Ah, yeah. Just get one, push it one like that. And now we take a look. We refresh. Nope, doesn't like it. Well, it doesn't like it because I haven't called the function. So let's resize the images and call in the source path and destination path. So we have an error here. Let's take a look. Unknown resampling. Mistake here. Yeah, new name new save is not defined, so now we have another one. Yeah, of course, new save, because I'm saving something that doesn't exist. And now we should populate this. Yes, there we go. Right. So if we check the dimensions of this now, should be 64 by 64 pixels. So we just have reduced the dimensions, and our random images are also now included there. Okay, so what we did is basically rename our files and resize our images, and now we're gonna get these images. So we're gonna import them. So let's create a function, call it getImages, and basically it's just gonna take in the path. Let's create a list, all images as array. Oh, keyboard shortcuts. And let's create label. And now you'll understand why did we have to rename the images, because basically we're going to create labels out of our images. So again, just go into our list directory with this path. Again, give me, let's try and accept. So let's start by if the file name has bird anywhere in it, I want you to append a one to my list here called label. Otherwise, just append 0. And when it appends 1, it's basically saying, hey, yes, there is a bird here, and no, there is no bird here. And this is just purely based on the file name, and that's why the structure here was very important. So open the image. And convert this image into an array. So in the previous video, in the previous videos, we've shown that you have to convert your images into a list of arrays or a list of values so you can give it into the neural network, since it won't be able to read images, since images is a type of unstructured data. Okay, so there's two things happening here. The first thing is we're creating our labels by looking at the file names. The second thing that's happening here is that we're simply opening the image and we're converting it to an array, and we're adding the array here. So in this if this function executes successfully, we end up with the images being converted into an array, and we have the labels. of those images based on the name. So exit the for loop and then just return the return your arrays. I'll just copy it from here. Give me an array of images and give me my labels as an array, as an NumPy array. This is just to ensure that it's reshaped correctly. So the -1 is just a notation, a shortcut notation, which basically means that the number of columns will be the same as the number of labels. So if there is 10 labels, then this will get 10. If there are 20 labels, this will get 20. Basically, if you know the size of your labels, then you can just put the number directly. Otherwise, -1 is just a lazy way to say, just get me the number and put it there. And you want it to be a column. And you wanted the x-axis or the x side kind of way to be the horizontal ones to be only one row, while the vertical rows to be as much as the training sets. So I'm just gonna quickly get my path. So the path to the train set, and of course you need to create your test sets. So this is a good time to separate your data. So just for your test set, you can randomly pick these. So I've just cut them and paste them here. So I'm just randomly creating my test set, and my random images are down here. And let's say I'm just gonna take these and cut them and paste them here. Okay, so I have now created my test set, which contains 43 birds and some other random images, while my train set has the rest of the data. So where did we stop here? So I'm just gonna copy my, yeah. So now I have given my training set and test set. And now I'm just gonna say original, since I will do some modification, entrance set y. Then we're gonna call this function here, and we're gonna give it our training set. So what we're saying here is get our images, and for our train set x, that will contain all our image arrays, and our train set y will contain the labels of this image. We're gonna do the same for our test sets. So we're gonna do test set x, and test set y. Again, get images. Right, so let's take a look at this. I think you just missed spelling here, because NumPy does have as array. There. Okay, so what we've actually just done now is create these variables. We can explore them really quick here. So if we take a look at this, there we have our label arrays, where basically 1 means there is a bird and 0 there is no bird. Same with the test set. Yeah, again, if you remember, these were the random pictures and these were the birds, and now the images are just a set of arrays. So we basically converted these images into set of array for the algorithm to deal with, and it's the same with this. We'll explore it now. But let's create the classes. Simply we have two classes. Basically, it's going to be the non-bird and the bird. We're going to convert that into also an array. I got a typo, I see it. Let's take a look at it. So it's a simple class with either a bird or a non-bird. Okay, now let's visualize our data set. Just think of a random number, 100, super random. I'm just gonna plot it here. So from our train set, you're just gonna pass it the index. So from our train set, show me image number 100. So there we see it's right there. If we change the number to 50, we get another image. We would also like to see, okay, what class does this belong to? So we can say convert this into a string. Let's make sure brackets are correct. Yeah, remove any unnecessary dimensions. Right, so one bird. So maybe we can say here the class is, or the y value is, let's do this, plus give it some space, and we can just say, let's give it also some space, the class is, right, so the value is 1 and the class is bird, full stop, right, the other way. So the y value is 1 and the class is bird, and if we change this to 300, still a bird, 400 is not a bird. Well, so then everything here should be a bird. Oh, this is not correctly labeled. Right, the class is a bird. So I'll go fix that in the training set before I upload it. Now let us get a general feeling of the data. So let's create 3 variables. Let's say the training set, the test set, and the pixels, just to understand how much training set do we have. And that's basically by looking at the shape. And I'll explain this now. Name shape is not defined, so we've done something here. Perhaps did this. Okay. So let me just quickly fast forward to this. So what we've done here, we can see that the number of training examples is 458, the number of test examples is 48, and the image size 64. Feel free to change this. So if we take a look at our train set, and we just print it, you get the arrays. Now if we just put in shape, we get these, and this basically means there are 458 images by the pixels or dimensions 64 by 64, and the color depth of 3. So the colored images have a depth of 3. The red, green, and blue should be the same for this. For the test set, you just get the amount of training examples is just much less, and shape 0 basically differs it from here, 1, 2, and 3. Okay. The next step is that we flatten and we reshape the data set, and this basically what it does is it takes the arrays and turns it into a column vector. So instead of having it like that, it just turns it into a column vector, and then it will organize the first ones will be the red, the next ones will be the green, and the one after that is blue. I mean, this is optional, but it's highly recommended by the literature. So let's create a train. We have to flatten both our train set and our test set. So we'll just do this. Take in my training set and reshape it to the. I'll show you a trick here. So just do this. And we do -1. Remember, I explained a bit earlier so that the amount of columns is the amount of training set. You can also literally put 458 now, since you know. Let's look at our test sets and reshape it again with this. And maybe print so you can take a look at the new shape. Okay, so if we do this, there you see the shape has changed from this to this. Now what happened here? At least you can tell that the 458 is the same, which is the -1, sorry, which is the -1 here, which is the amount of training set, but everything else, so this here is actually the multiplication of this tree. So this is just a short for, let's create this temp, so you can take a look, print it. So this here actually means 1. So if we just copy this here, dot 2 dot product, three, and the -1 is literally this here. So if we do this, give me the shape, and then it's the transpose of this. No, you actually have to remove the transpose here. You don't need this. There you see, it's the same value. So basically this is just the short form for these three here, and the -1 is the number of shape, and you transpose it to get it correct. It's just a NumPy trick, or shorthand form. So now let's get rid of these. So now we have flattened our training set and test sets. So what we have here is 12,288 vectors going this way, and 458. So if you would imagine this, don't have my pen right now, but if you would imagine this, the 458 goes this way. So this is the number of examples we have, and then column in this way, the column wise, it will be these values here listed. So 12,228, 12,000, and this is basically all the RGB colors containing all these pixels values. The literature also recommends to standardize it. So the RGB goes from up until 255. It's just the value. So you just standardize it, and there's a lot of reasons why you should do that. Can also add a link for the literature below. So now we have taken in, we've taken our train set flatten and our test set flatten, and we've now created our train set X and our test set X, which are flattened values. And this is basically what we've done in the pre-processing area. We've imported our images. We renamed our files, so we can create labels. We resized them, then we imported them, creating our label and all images as array. We created some classes. We have visualized our data set. Then we've got a general feeling. How many training examples do we have? How many test examples do we have? And then we reshape them into this here by having, well, every image now is basically a column vector, and then we put them together, and then we standardize it. And this is basically the data pre-processing part. In the next lecture, we will now start building our building our neuron, actually. Here we see the mathematical expressions that we've described, or we went through in the past lectures. And we're gonna look into these steps. See you in the next video.